In this episode of Mr. Lamit's Knowledge Explosion, we're going to talk about how to find the area of these special quadrilaterals that we have been talking about. Now, some of these shapes you've been finding the area of for a long time, so I'm not going to bore you with the details of those formulas, but we'll do an example of each to make sure. For example, the area of a square, the formula we use is the area is equal to s squared, where s is equal to the side length. So in this first example, my side length is 6, so my area will be equal to side squared, which is equal to 6 squared, which is 36. Now we should be specific in the measurements we're talking about. Since it was a 6-inch side, we would say this is 36 inches squared. Rectangle, again, you're probably familiar with. The length of this rectangle would be 10. The width would be 4. So the area is going to equal the length times the width, or 10 times 4, which is 40. So we would say this has an area of 40 meters squared. Now the parallelogram is very similar to the rectangle, but we don't say length times width, we say base times height. And the important note that you need to make sure you catch here is the height must always be drawn perpendicular to that base. So you'll notice we have this right angle symbol showing that that is the height. Okay? So that means that my base is 12 and my height is 10. So the area of this parallelogram is going to be the base times the height, or 12 times 10, which would be 120, in this case, centimeters squared. So those three examples most people are familiar with, and we can do those very easily. You're also probably familiar with the idea of the area of a triangle, which is 1/2 the base times the height. Some prefer the method base times height divided by 2, but that's just an algebraically different way of writing it. So for this one, again, you need to note that the height must be drawn perpendicular to that base. True for this and trapezoids. So my base here would be 16. My height is 9. So I'm just going to plug that into the formula. It's 1/2 the base of 16 times the height of 9. Now I usually do 1/2 of whatever the even number is, so half of 16 would be 8, still times that 9 would be an area of 72 meters squared. The trapezoid, this one may be new to you. The formula is 1/2 base 1 plus base 2 times the height. So it's saying we need to add the sum, so 2 plus a base of 8 multiplied by the height, which is 5, and then like the triangle, we do half of that. So this is going to equal 1/2 of 10 times 5, which would be half of 50, for a total area of 25 centimeters squared. So make sure you know that formula and what those symbols are representing in that formula. Ones that may be new to you are the rhombus and the kite. The nice part is they both use the same formula, 1/2 diagonal 1 times diagonal 2. So when you see D1, that's talking about the length of the first diagonal, and D2 refers to the length of the second diagonal. So we may have to use a few properties of the rhombus to figure this out, but what we have is this. This length of the rhombus is 6, and since we know it is bisected as a diagonal, it's also 6 on the other side. So diagonal 1 in this example would be 12. The other diagonal, half of it is 3, so the other half is also 3, so that diagonal 2 is 6. And then to find the area of this, we would say the area is equal to 1/2 of those two diagonals multiplied together, or 1/2 of 12 times 6, which is equal to 1/2 of 72, which would then be 36, and this was inches squared. Kite's going to be the same thing. It's going to be 1/2 diagonal 1 times diagonal 2. So sometimes if you see this outside of the shape, that's okay. That's still showing you that from this point to this point is a total length of 12. So that first diagonal has a length of 12. And the second diagonal has a total length of 4 plus 4, which is 8. So we use the same formula and we say that the area is equal to 1/2 of those two diagonals multiplied together. So again, in this case, 1/2 of 12 would be 6, multiplied by the 8 would be 48 inches squared. Those are the basic formulas that you need to know to answer the questions. So I want you to try and answer the questions in the following examples. That's where I'm going to stop this video, and in the next video, if you would like to watch it, we'll walk you through those examples to make sure you're getting them correct.